Okay, all right. So I obviously want to go back over this again because solving cubic equations is really, really important. And this is sort of your first step to being able to solve the x-intercepts of a cubic function. And there is no doubt in my mind that this is something that they will ask you in the upcoming trials. And it's definitely something that you'll be asked at the end of the year. I'm fairly certain of that. Well, if they set a sort of normal standard question, if they do something weird and interesting, then maybe not, but hopefully. But this is generally something that always gets asked. Okay, so I'm going to start with the basics. And if you need me to move faster or you don't understand, then you're welcome to say so. All right, so when we are solving now, I'm starting off talking about quadratic equations, all right? When we start off solving a quadratic equation, such as x squared plus 2x minus 3 equals 0, what exactly does this mean? What are we trying to do here? Can anybody tell me? What is it? If somebody asked you to explain what this means, what are we doing? What are we trying to calculate? Isn't it interesting how we solve questions like this all the time in class? Sure. Okay, so you're solving for x. Cool, lovely, I like that. Okay, so you are calculating the value of x when the value of y is 0. Okay, so you're calculating the values of x, all right, for which y is equal to 0. That's what it means. Okay, so we are calculating the values of x for which y is 0. Okay, so you're right, that's what it means. What information does this give us? So if we make y equal to 0, what are we going to be calculating? Which specific x values? Which specific x values are we calculating? Aha, there we go, Mishali. Lovely. And Tamika and Mpilo. Perfect. Okay, so we are calculating the x-intercepts. So that specifically means the values of x where the graph cuts the x-axis. So if I go over here and my red graph depicts the graph that we were just talking about, right? When I make this equal to 0, all right, so when I take, it's right, don't have red. Okay, if we take x squared plus 2x minus 3 and we make it equal to 0, and we now want to work out what is the value of x over here where y is equal to 0, and what is the value of x over here where y is equal to 0. What's our next step? We have to, what's the step called? This step is called factorizing, 100%. Okay, so we factorize to find the x-intercept. So in this case, our x-intercepts would be, well, our two factors would be x plus 3 times x minus 1. So that means that we have one x-intercept where x is equal to -3, or the other x-intercept where x is equal to 1. This one over here is the one where it's equal to -3, and this one over here is the one where it's equal to 1. Really, really straightforward. When we are solving, lovely guys, well done, perfect. So when we are solving a cubic equation, we are doing exactly the same thing. We are trying to find the x-intercepts of the cubic function, all right? And we do that by factorizing as well, okay? The difference is this, okay? When we have a quadratic expression, like the one that I've got on the board at the moment, it's a binomial times a binomial to give us the quadratic, okay? So what I'm saying is this: we are multiplying one binomial by another binomial in order to get a quadratic equation. When it comes to cubic functions, right, because they are cubic, let's go back down over here, right, there are going to be 3 brackets or up to 3 brackets. So in other words, if I end up with I'm going to make something up here. All right, so let's say I've got x minus 1 times x plus 2 times x minus 3. All right. In order to get a cubic, there have to be 3 binomials that are being multiplied together, or it has to be a linear factor multiplied by a trinomial, which you would then go and factorize. Okay, so because you have 2 values for x for a quadratic, there are 2 brackets. Because you can have up to 3 x-intercepts for a cubic function, there can be up to 3 brackets. Okay, which is another thing that I wanted to point out to you before we get started. All right, now in a cubic function, all right, your cubic function can either be this shape, all right, or it can have this shape. Okay, now the shape of the cubic function at the moment is not really important. What I'm going to do is I'm going to draw a straight line. Okay, there's my straight line, and I think I want to make my straight line a different color. Okay, so this represents my x-axis, okay? Now, if I have my x-axis over here, how many times does the purple graph intersect the x-axis? Once.
It intersects once.
It only intersects once. So I have one solution for x in this case. Now I'm going to draw another straight line, okay? And this time I'm going to make my straight line purple, okay? Hold on a second. I'm going to move this line. It's not in the right position just yet. There we go. Now, how many times does the dark purple line intersect the light purple line? Twice. Okay, so there are 2 x-intercepts in this case, quite right. Okay, so there can be 1, there has to be at least 1. There can be 2, and now if I draw yet another example of an x-axis over here, if it goes through over there, how many x-intercepts do I have now, Matrix?
3.
I have 3. Excellent. Okay, so I can have 1. I could have 2 if one of the turning points lies on the x-axis, and I can have a maximum of 3. Okay, so that's very important that you understand that, and you know what it means, and you know what you're looking at, what it represents. Okay, so in the situation of the orange one, that's like what we can see over here. Okay, so where we've got 3 different x-intercepts. All right, and I'll explain what we would expect with the purple and the green one now. Okay, so that's why it says here the standard form of a cubic equation is ax cubed plus bx squared plus cx plus d equals 0. And cubic equations must have at least 1 real root, but may have at most 3 real roots. Consider the following example. So now we're going to work through these together. Okay, so just like with a quadratic equation, remember we had to get everything over to one side equal to 0. It's the same with this. So our first step over here for question number 1 is to do what with it? We need to get it into what's it called?
Factors.
So we have to get it into standard form.
Standard
Okay, so
form.
that means we've got to put everything together on one side of the equal sign. So that means we've got 2x cubed plus 5x squared minus 3x equals 0. Right? Now we have to remember our rules for factorizing. So what's the first thing we scan for? Matrix? Yes, okay. Make it equal to 0. Quite right. Now what do we look for?
The cube.
We're going to look for factors. Absolutely, we're going to look for factors. Now, this particular cubic, all right, has a D value. So this D that's here, this D value, all right, what is the value of D in question number 1? Ah, there we go, Mihlali. You've got the right idea. Okay, exactly. All right, so I remember I've spoken to you before. Is it Leroy? It is 0. Okay, Amanda, yes, it is 0. So that means that this particular graph, okay, goes through the origin. The origin is going to be its y-intercept, and we're going to see it's also going to be one of its x-intercepts. It's going to end up the x-intercept and the y-intercept, at least one of them is going to end up being the same. Okay, so we take out a highest common factor of x in this case. That leaves us with 2x squared plus 5x minus 3 equals 0. Okay, and now again, we have to factorize. So we're going to leave the x on the outside, factorize our trinomial. We're going to have 2x over here. We're going to have x over there equals 0. Remember, when you're solving for x, guys, it has to be equal to 0. Don't drop that off. Normally, they give you an accuracy mark on this line, and if the equal 0 is missing, that mark is down the drain. Okay, so we don't want to lose that mark. All right, now we've got to figure out how to factorize this trinomial. Where am I going to put 3 and where am I going to put 1, Matrix? I've got to place a 3 and a 1 into the second spot over there. Where am I going to place them, do you think? On your right. Okay, so does the 3 go over here, Amanda? And the 1 goes there. Is that what you're saying? Yes, I agree with you, Amanda, right? Because now what we're trying to do, well, what we've done so far is we've said that 2x times 1x gives us 2x squared, and we've said that 1 times 3 gives us 3. Now, Amanda suggested that we put the 3 in the second bracket so that when we do the O part of FOIL, the outers, we want to end up with plus 6 minus 1 to give us the plus 5 in the middle. Okay, so nicely factorized. Well done, Amanda. And now we have 3 solutions for, okay, so 3 distinct solutions for x in this case. So either x is equal to 0 or x is equal to 1 over 2 or x is equal to -3. So this kind of cubic looks like the one, the orange one. Don't worry, I'm going to go back there now, like that, where there are 3 distinct roots. Okay, 3 different roots like that. Okay. We won't worry about its shape for now, but it is also concave down and then concave up. Okay, good stuff. Everybody happy with that? Can we move on to the next example? Any questions? Cool. Okay, all right. You interrupt me if there are any questions you want to ask. Okay, guys, I'm moving on to the next one. Lovely. All right, now we've been given 8x cubed plus 27 equals 0. All right, now we need to solve this cubic equation. Now, can you see here what's different here to the one above is that there's no x squared term and there's no x term. But we've got the ax cubed term and we've got the d term. What do you think we should do here, Matrix? How would we solve this one? Absolutely, Primrose. Okay, quite right. The first thing that we need to do, Primrose, is this. We need to leave the 8x cubed on one side. Actually, cube root each number. Absolutely, right? Now this, okay, you guys are on the right track. This, I don't know if you remember this from grade 11. This is a throwback from grade 11. And this is called sum of cubes. Do you remember sum of cubes? Okay. So sum of cubes. So if you recall, sum of cubes, or I suppose there's another way that we could do this if we wanted to, if we make it equal to 0. We could do this. We could say 8x cubed is equal to, and then we can take the 27 over to the other side. I can divide this side by 8 and that side by 8. And now I've got x cubed is equal to negative 27 over 8. And I can now factorize. I can now cube root, sorry. So I'm going to cube root the left. I'm going to cube root the right, and that's going to give me x is equal to negative 3 over 2. Okay, so I only have one solution for x in this particular case. Only one solution for x. Probably the easiest way to do it rather than factorizing sum of cubes. Does that make sense to everybody? So when something like this happens with a cubic equation, what we are looking at, Matrix, is this scenario over here, all right, like the green one. Okay, so there's only one x-intercept, okay, in a situation like this. And now let's go back down here. Can we factorize cubic polynomials? In which camp are you sitting? Can you factorize cubic polynomials? Yes. Or is this something that we are struggling with? So if you can put that into the chat for me, either a yes or a no, then I know where to focus my attention. Can you factorize a cubic polynomial? Quite easily. Okay. All right. So a lot of you are saying no. Okay, perfect. Let's focus on that, because in order to solve a cubic equation, we have to be able to factorize a cubic polynomial. Okay, so we have to acquire those skills first, all right? So let's focus on that. So here I have given you f of x equals x cubed minus 4x squared plus x plus 6 as far as possible. All right, now what I want you to understand is this, okay? Before we actually go and work out that, where this comes from is this. So let's pretend I've got 3 brackets. I can take those same 3 brackets I was talking about earlier. Let's say I've got x minus 1 times x plus 2 times x minus 3, okay? If I leave my x minus 1 outside for now, this is now me doing products, okay? So x times x, this is FOIL, is x squared, minus 3x plus 2x is minus x, and positive 2 times negative 3 gives me minus 6. So now when I want to multiply my binomial with my trinomial, I say x times x squared, that gives me my x cubed term. Did you all see that? So this guy here times this guy here gives me that one. Then I'm going to say x times minus x, so that'll be minus x squared, minus 6x. Now I'm going to multiply the minus 1 into the second bracket, so that's going to be minus x squared plus x. I'm just checking my signs, minus x squared, minus x, minus 1, plus x. And then the last ones here, let's just highlight them as well. Okay, so this guy over here times that guy over there. Minus 1 times minus is plus 6. So that's how we get a cubic polynomial. Minus x squared minus x squared is minus 2x squared. Minus 6x plus x is not plus, sorry, it's minus 5x plus 6. Now, the reason that I am showing you this is so that you understand the process. When you were in grade 9, or maybe even grade 8, probably grade 9, they gave you this line over here where the purple star is, and you did this, which is finding the product. That's multiplying out. So starting with factors and producing terms. Now that you are in matric, we are starting over here with the 2 purple stars. We're starting with the terms and we are producing the factors. That is what we're doing. Okay, so in order to be able to solve a cubic equation, we have to factorize a cubic polynomial. All right, so we're starting at this point over there and we are working backwards. So the first thing that we want to do, right, is work out the linear factor times the trinomial. And once we've done that, we can then factorize our trinomial like we always do into our further 2 brackets. So let's take this one over here as our example. If we do not know what the linear factor of our cubic polynomial is, we have to pick up our calculators. Has everybody got their calculator? Okay. And now we have to try, right? Now, whatever factor we use has to go into 6 as well. So it could be 1 or minus 1, 2 or minus 2, 3 or minus 3, or 6 or minus 6. I don't think we're going to have to go up that far. Everybody start with 1. So you're going to sub 1 in. So in other words, what you're doing on your calculator is you are working out 1 cubed minus 4 times 1 squared plus 1 plus 6. What does that give us? Does it give us 0? No. Okay. All right. Perfect. Let's try negative 1. We're using factor theorem here. Does this give us 0? Ah. Okay, lovely. So if f of minus 1 is 0, what does that mean, matrix? So if f of minus 1 is 0, what does that mean? Okay, it means, yes, Cassandra, it means that x, sorry, my pardon, let me just get rid of that, that's nasty looking. It means, guys, that x plus 1 is a factor of f of x. Okay, can you see how the sign has changed inside the bracket? So we get this value over here by making it equal to 0 and taking it over to the other side. Okay, so that means that x plus 1 is a factor. Is everybody happy with that? So what we know is this, that it breaks down into x plus 1, and then we have our trinomial. And I'm going to call it ax squared plus bx plus c. Okay, and now it's going to be our job to work out the coefficients a and b, and it's going to be our job to solve the constant c. We need those values first before we can continue to factorize. Okay, so this is what we do. Remember, over here, the only way that we could get the x squared term was to multiply the x in the first bracket with the x squared in the second bracket. Okay, so now again, if we go back here and we have a look, the only way that we can get this x cubed term up here, and I highlight it in yellow, is by multiplying this guy with this guy. So this method is called inspection, because what we see is that when we multiply x with ax squared, we get ax cubed. And then when we go up here and we look at this, we see that it is 1x cubed. And therefore, we say, well, a has to be equal to 1 in this case. Okay, so that's step number 1. Our second step is to work out the value of c. Now, if you recall from the example on the right, the only way we got the number at the end was by multiplying the last term in the first bracket with the last term of the trinomial. That's how we get this number here. So in other words, what this means for us, matrix, is that when we multiply 1 and c together, we end up with 6. So that means that c is 6 in this case. The last thing that we need to work out is the value of b. Now here, if you go back and you have a look here, all right, this is b over here, the x squared term. Can you see that it comes from more than one place? Okay, it's this guy here combined with that guy there. How did we get those terms? Well, this first one over here that I'm just currently making bigger was obtained when I multiplied these two together. And this one over here was obtained when I multiplied those two together. So I need to do the same on the left-hand side. What I'm going to do is I'm going to have a look at, use a different color here, orange, this one times this one, plus this one times this one. Oh, hang on, sorry, I drew it to the wrong place. Hold on, sorry. This one, silly me. This one times this one, sorry. Okay, so to get your x squared term, right, so what we've got here is x times bx, that gives us bx squared. 1 times the value of a is 1, so 1 times 1x squared gives us 1x squared. We have a look at what it equals up here. It's equal to minus 4 x squared. So this means for us matrix that b plus 1 is -4. Okay, so we can essentially drop our variables and we can work just with the coefficients. And now we can solve b. So we're going to take the 1 over to the other side, it becomes -1, and then we're going to end up with b being equal to -5. All right, how's everybody feeling at this point? You can put something in the chat, either a smiley face or a sad face. Is this good? Are there any questions? Is there anything you need me to clarify?
Leroy said it's giving us a thumbs up.
Oh, okay.
And smiley faces. Tanako has a question.
Okay, that's fine. Just the last part. I realize, I know that that this is difficult. And when you understand what you're doing, it actually becomes really, really easy. Okay, so just the last part again. Okay, guys. So this method, by the way, is called inspection. So let me just go back here. Maya, I see you had a question. Where did you get the 1x squared? Okay, so Maya, in order to get x cubed, you can only get x cubed by multiplying x with x squared. Does that make sense to you? So you can only get x cubed from multiplying x squared with x. Right, so when a cubic polynomial factorizes, it's always going to factorize into a linear factor and a trinomial. Okay, and then that trinomial will obviously have its first term as an x squared term. Does that make sense, Maya? Cool. All right, so guys, in order to get, just get rid of those again. So in order to work out what this b term over here is going to, what its value is going to be, work out b last. Okay, well, you can work out b second if you want to. You need to know the value of this a over here before you can work out b. Okay, so what you need to do is you need to multiply the first term in the first bracket with your bx term. That gives you bx squared. So x times bx is bx squared. And then you need to multiply the second term in the first bracket with the first term in the second bracket. So because a is equal to 1, we are multiplying 1 with 1x squared. Okay, and that gives us plus 1x squared over here. So it is the sum of those two that gives us our x squared term up here. All right, so that's why we are making it equal to minus 4x squared, okay, because that's what we see it equals. All right, so this is how we undo this bit over here. All right, so what we're having to undo here is this bit here. We're undoing that and that. Okay, so we're working out what this has to be and what this has to be in order so that we can get this bit here. Remember, we are working backwards. We're starting here and we're working back up to the top. All right. Now that we know, and then once you've got your bx squared plus 1x squared equals minus 4x squared, you are now dropping the x squareds. Okay, so can you see how the x squareds are now gone? And we're just working with the coefficients. So b plus 1 is minus 4, take the 1 over to the other side. So what we've got now, matrix, sorry, I'm just going to have to work in the wrong place here, is we've now got x plus 1, our first bracket, multiplied by x squared, b was negative 5, okay, and c is equal to 6 in this case. So there we go. We've done it. We've got our linear factor, that's the first bracket, and we've got our quadratic factor, that's the second bracket. And of course, if we can factorize this trinomial, then we need to go ahead and go and do so. All right, so now we're having a look at it. We can see that we've got to have two numbers. When we times them, it gives us 6. When we add them together, it's got to give us -5. So because this middle term is negative and the last term is positive, both brackets have to have a minus in them. Okay, and obviously one bracket would be 2 and the other bracket, whoopsie, be nice if I put a sign in there, wouldn't it? And the other bracket would be -3. Okay, and now your expression is fully factorized. The only difference between this and what we're doing is that we now, if we want to solve the x-intercepts, we've got to take this and make it equal to 0. Okay, so it has to be equal to 0 before you can solve the x-intercepts, because remember, y is 0 all the way along the x-axis. All right, so if we did want to solve for x here, all right, so we say here and solve f of x equals 0, we can now write down our solutions. X equals -1, or x equals 2, or x equals 3. So this particular cubic polynomial cuts the x-axis in 3 different places. Okay, how are we feeling? Okay, good stuff. All right, now I'm going to be quiet with Neliswa for a little bit, okay? And you guys are going to try this question. All right, I'm going to answer your questions now. I just want to give people work to do. So you're going to factorize g of x, okay? And let g of x equal 0 to solve for x. Okay, so if you're feeling confident now, you go ahead and go and jump into that. There was just one question. Katluano, where did the 6 come from? Okay, so Katluano, the 6 came from over here, right? So in order to get that blue term at the end here, this term here, we multiply these two together. Okay, so 1 times c is 1c. And then if you look up here, it was equal to 6. So we make it equal to that. That's that over there. And that's why c was equal to 6. It just depends on what this value is here. I mean, you could have 2c equals 6 or 3c equals 6. And then obviously the value of c would be different. Okay, but that's where it came from. Okay, Matrix, give that one a try. And let's see what you come up with. It's a pleasure. I'm just going to get my calculator. I will be 2 seconds and I'll be right back. Okay, Neliswa?
Okay.
Thank you. Just 2 seconds. Sorry, it was right at the bottom of my bag. There we go. Are we okay here? I agree. X minus 1 is a factor. Yes, 100%. Well done, Mpilo. Cool, Michali. Well done. That's it, perseverance. Very nice. Well done. It certainly does. Good job. Well done, Riabulwe. And then what you'll see with practice, this just becomes easier and easier and easier. Okay, so I'm just going to make it equal to 0 for now because I'm solving for x. And you said that x plus 1 was a factor, is that right? Was it x minus 1? No, it would be x minus 1 is a factor. Oh, there we go, x minus 1 is a factor. Good. Okay, and then over here, we would have ended up with x squared. So I would have had plus 8 at the end. And then here with my bx term, I would have said x times bx, and that would have given me bx squared, and minus 1 times x squared, and that would have given me minus 1x squared, and that would be equal to 5x squared. So b minus 1 is 5, which means that b would be equal to 6. Okay. All right, and then once you've got that, you can then factorize further. So this is where the x plus 2, x plus 4 comes from. And now that we've done that, we can say either x is equal to 1, or x is equal to -2, or x is equal to -4. Okay. How's that feeling? Did everybody get that right? Are there any questions? Okay, so seeing that there are no questions, I'm now going to go back up here, all right? And I'm going to ask you to solve this one, which is the one that we were originally. Okay, so now, if this was in an exam, all right, normally when they ask you to solve for x, or calculate the x-intercepts of the cubic function, you're looking at something that's worth about sometimes 4, maybe 5 marks. Let's say 4 marks. Okay, so you can't go straight to the answer matrix, because if you just write down the answer only, you're only going to get 1 mark. Okay, if you get 1 out of 4, you have not passed. You've only got 25%. So you've got to show the steps. All right. So now that you've done so well on that one, I want you to try this one. This one has a little trick to it though. What's it missing? And I'll give you the hint before you get started. What's missing here that you've noticed? Can anyone see what's missing in equation number 3? Aha, correct. The x squared term is missing. So what will be the coefficient of the x squared term in question number 3? What will we use as its coefficient? There we go. Okay, we'll use 0. Good, guys. Well done. Yes, Raul, it is the x squared term. Good job. Okay, so we will write that as 0x squared. Okay, so I want you to do what we've done, all right, where you're going to find the linear factor, factorize the trinomial, and then solve your equation. Okay, off you go. Okay, Mhlali, you're quite right. Good job, Mhlali. Well done. Yes, Rebelwe. Quite right. Now here we are seeing 2 solutions for x. Okay, so this is what I've showed you today. I've shown you a situation where we've had 3 solutions for x. Then we've seen how we can have 1 solution for x. And now we've seen the last situation where there can be 2 solutions for x. Okay, and this is important for us because We're going to see on Thursday when we talk about the characteristics of the cubic function, and there are two solutions for x, what this means. It has a very specific meaning. Indeed, Leroy, x is 2 or x is -4. Okay, nicely done. And there are just a few more there. If you wanted to practice those. We've got just a few minutes left. Again, what you would have done here, guys, is you would have picked up your calculator. We never say that in maths. It's always the last thing we do is pick up our calculator, not the first, but we would have picked up our calculator in order to find our linear factor. So either we could have started with x minus 2 as our linear factor, or we could have started with x plus 4. All right, so it really doesn't matter. Let's say you started with x minus 2, okay? Because you discovered that f of 2 gave you 0. Then over here, again, you would have had your ax squared plus bx plus c equals 0. And of course, it's our job to then work out the values of a and b and c. So at a quick glance, we can see that ax cubed is equal to 1x cubed. So that means that a has to be equal to 1 minus 2 times c. Oh, hang on a second. I'm naughty. Sorry. I didn't get it into standard form first. So this needs to be x cubed plus 0x squared minus 12x plus 16 equals 0. Sorry, standard form first. Okay, now we're using x minus 2. Then it's going to be the multiplication of x and bx to give us bx squared minus 2 times ax squared. A is equal to 1, so that's minus 2x squared is equal to 0x squared. So that's where that 0 is coming in. Okay, so b minus 2 is 0, so that means that b has to be equal to 2. And then the last one here, guys, is minus 2 times c is going to be equal to positive 16. So that means that c has to be equal to -8. So what we've got is x minus 2 times x squared plus 2x minus 8 equals 0. All right, we have to factorize that trinomial now, because it will factorize. And in one bracket, we're going to have a 4. In the other bracket, we're going to have a 2, because the middle term is positive and the last term is negative. That means the bigger of the two numbers is the one that has to be the plus. And so we end up with a situation like that. Okay, so what we see, and this is what I'm going to discuss next time, is that this bracket is repeated. That is significant. That means something very important for us in terms of our graph. I'll talk about that next time. So either, guys, x is equal to 2 or x is equal to -4. Okay, that's